Hi, welcome to a new video about math problem solving. My name is Bharat Divya, and today we're going to be doing an astronomical problem. Let's get started. Which is bigger, the total number of atoms in the universe or the number of possible chess games? What do you think? Let's go look at it. So let's start with the chessboard. Okay, this is the starting position. There are a total number of 16 pieces on each side, but not everybody can move in the very first move. How many possible moves are there to begin the game? So, did you observe that only pawns and knights can move? The very first move, and each one of them can possibly make two moves, right? So, the pawn can move either one step or two steps, knight can move to either left or right. So, in other words, the total number of possible pawn moves is 16, the total number of possible knight moves is 4. Black would move same as white, so white has 20 moves, black has 20 moves, and the total possible number of games, if a chess game were to stop after just one move, would be 400. And as the moves increases, the number of possible games also increases. Right? Just assuming the same 20 for the second move would be like 400 times 400. So as you can see, the number exponentially increases. So let's make a few assumptions. Let's assume that the game lasts for 40 moves. The first 5 moves is 20 possible moves. The rest of the game is 30 possible moves. So the total number of possible games after just 5 moves is 20 times 20 to the power 5. As I said, it's 400 times 400 after 2 moves, which means that's the same as 20 times 20 power 2. But after 5 moves, it will be power 5 because you've got to keep multiplying it to see the total number of possibilities. So after you account for the next 35 games or 35 moves, the total number of possible games would be 20 times 20 power 5 times 30 times 30 power 35. So which is bigger now? The total number of atoms in the universe or the number of possible chess games? In other words, I can think of first, let's see how many atoms are there. So this is from just a brief Google search, which says that the total number of atoms can be estimated to be 10 to the power 78 to 10 to the power 82. We'll probably do another video on exactly how to estimate this value. But as of now, let's assume this. And now ask the question, which is bigger? Is 10 to the power 82 bigger or this number that we arrived at, which is 20 times 20 power 5 times 30 times 30 power 35. Which one is bigger? Now, no calculator or even a computer is going to give you the exact value. So you need to have your mathematical skills to try and convert the second number into something that's comparable with the first number. So you can measure apples against apples. Okay, let's take the first term. So I have 20 times 20, which I can do as 2 times 10 times 2 times 10. Therefore, segregating the 2's together, it's 2 times 2 and 10 times 2. 10 times 10, 10 to the power 2. The whole thing to the power 5, leaving me with 10 to the power 10 times 10 to the power 2 to the power 10. Now, here's where the approximation comes in. 2 to the power 10 is the same as 10 to the power 3. You might be surprised how. So let's look into it. But if you assume that, then the first term ends up as 10 to the power 13. Still much lower than the number of atoms, right? So let's list down all the powers of 2 and powers of 3. And here are the approximations that I would look at. So 2 to the power 10 is 1024, which is approximately same as 1000, which is the same as 10 to the power 3. For 3 squared is 9, which to me is the same as 10. And 81 is the same as 80. And 80 is nothing but 2 cubed times 10. Let's keep this in mind as we go to the second term. So doing the same thing, I would arrive at 3 square power 35 times 10 square power 35, which is nothing but 3 to the power 70 times 10 to the power 70. If you feel you're not following at any point of time, just pause the video and look at the previous step and how I've arrived at the next step. Now what I'm doing is 3 to the power 70, I'm dividing that as 2 and 68. So 3 to the power 2 times 3 to the power 68. Now why would I do that? Because 3 square is same as 9, which I can approximate to 10. And 68 is nothing but 3 to the power 4, which is 81, which can be approximated to 80 power 17. So let's do that. So I have the 10 added to the 70, so it becomes 10 to the power 71, and 80 times power 70. And 80 is nothing but 8 into 10. So I can split that as 8 power 17, 10 power 17, 10 power 71. Combining the 10s together, I get 10 to the power 88. At the same time, 2 cubed is the same as 8. So, or I can basically split this as 2 to the power 3 times 17, which is 2 to the power 51. Now again, I need to make this simpler. So 2 to the power 51, I can split it as 2 times 2 to the power 50. Why am I doing this? Because I can rewrite 50 as 2 to the power 10 power 5. And 2 to the power 10 is nothing but 1000, which is 10 cubed. And therefore, it's 2 times 10 to the power 15 times 10 to the power 88, giving me 2 times 10 to the power 103. So now let's go back and ask the question, which is bigger, 10 to the power 82, the number of atoms, or the first term evaluated to 10 to the power 13 and the second term evaluated to 2 times 10 to the power 103. And combining that out, it's 2 to the power 2 times 10 to the power 116. Now we have a clear winner, right? Because the number of atoms is just multiple orders lesser than the number of possible chess games. So what's the next step and the lessons that we have learned here? Chess is bigger than the universe. So that's the reason for everybody to learn chess. It's the art of approximations in math. So whenever you're doing these estimation problems, you need to learn how to approximate it. You have to understand the scale of numbers. You can't get tied up saying, how can I make 81 into 80, or how do I do 1024 into 1000? When you're dealing with 10 to the power 82 and 10 to the power 116, these numbers are extremely small. So you can make these approximations. And I think a lesson here is that numbers come in handy all the time. So getting a sense of how these numbers are, how you want to convert from one to the other, this versatility that I've been talking about comes in handy in solving these complex problems. Ultimately, math is how you understand the universe. So if you like to understand the universe a little bit better, please do like, subscribe, and share this video. Thank you so much.